Welcome everyone. Thank you for taking the time to watch this today. My name is Carlos Zaskorski and I am a product manager with FireEye. And today's presentation is an introduction to flame safeguards. I'm going to have everybody muted for the presentation and I will be available for email for any questions to follow up. First of all, this is an introduction to flame safeguards. The first half will be the sequencing of the flame safeguards, followed up with an introduction to, or a FireEye overview of our products. So let's start. So the basics. What is a flame safeguard? A flame safeguard is a device that controls the safety aspects of establishing and maintaining a flame. The design of the flame safeguard is usually defined by codes that the manufacturers of industrial process equipment must adhere to. So basically the flame safeguard is the part of the burner that establishes the flame, makes sure that the flame is present, and establishes the sequences to get that flame established in the first place. So why use a flame safeguard? Safety is the top priority with any industrial process. As a result, the liability that an individual or company would assume if they were to create their own flame safety logic would be enormous. So what does that mean? That means you could establish a flame using PLCs or other logic, but there is liability involved with that. So when you choose to buy a flame safeguard from an established manufacturer like FireEye, you don't have to worry about that aspect. You can rely on the years of experience and maturity of the product and know that the industrial process will operate smoothly. So safety codes must be considered in the design of a flame safeguard if it is going to be used in any application. Jurisdictions will usually require compliance to codes as well, and there are also other local codes in certain places. So in some cases, code compliance can be achieved other ways, but it is best to factor into the flame safeguard the codes that you need to adhere to. And here are some of the codes listed: NFPA 54, NFPA 85, NFPA 86, and ASME CSD1 are some of the common codes. There are also a number of regulatory agencies that provide listings that allow equipment to be installed. It indicates that the agency has tested and approved the safety of the device within the defined category. So one that everybody's probably heard of is UL, and you can see on the logo it has a C and a US. That means it is listed in both Canada and the United States. There's also CE, which is a certification mark required within the European Economic Area, which is primarily EU countries. And then there's FM approved, and FM Global is an insurance company, Factory Mutual, that specializes in loss prevention, and they also offer testing and approval services. So most FireEye products are going to be listed with one or more of these agencies. To find out which agency approvals are required for the jurisdiction, first you want to find out which agency approvals are required for the jurisdiction that the equipment is going to be installed into. And then in the documentation for the flame safeguard, you can find which models are in compliance with those listings. So for flame safeguards themselves, there are two primary categories: the primary control and the programming control. And these are really just terminologies. So the term primary control typically will refer to a more basic control that doesn't have a modulation circuit. So it will typically control an on-off burner. Most primary controls on the market now are microprocessor controlled, but historically many of these use mechanical devices or mechanical timers to achieve the sequencing. And the term programming control typically refers to a more advanced control that controls modulation or has other advanced features. Programming controls are almost always going to be microprocessor controlled. So the main parts of the flame safeguard are the wiring base, chassis, programmer, and amplifier. And these will come in different pieces so that you can mix and match to get exactly what you need out of the flame safeguard. So first is the wiring base, and almost any flame safeguard system will begin with the wiring base, also known in some cases as a sub-base. The wiring base is where all the connections are made. What's nice about a wiring base is it allows the flame safeguard to be easily removed for testing or replacement. Next is the chassis, and the flame safeguard chassis is what binds all of the components together to form one functional unit. The other components, such as the programmer or amplifier, can either plug into the chassis, or in some cases one or both of those can be integrated into the chassis. When integral, the type of amplifier desired must be known prior to getting the chassis because it can't be changed so easily after the fact. The programmer is what contains all of the operating logic. The sequences and timings are all contained in the programmer. The model selected is based upon the application, and while many of the settings are initially programmable, such as timings, there are provisions with all programmers to burn in these settings after a certain amount of runtime, which is typically going to be 8 hours. The amplifier determines which type of flame scanner the flame safeguard can work with. The amplifier may be integral to the model of chassis chosen. In some cases, the chassis model will determine the flame scanner that you can use. Other models have an amplifier card similar to a programmer card, which means you could change it. The typical types of flame scanning supported by amplifiers are flame rods, ultraviolet, and infrared scanners. The flame safeguard has dedicated inputs and outputs for all of the required components in the process. There is a non-recycling or safety input that is monitored whenever there is an active cycle. And if any device in this loop trips, the flame safeguard will lock out and require a manual reset. So items in that limit string are typically devices that should not normally be tripped, such as high temperature or high pressure limit or gas pressure switches. Then there's also a recycling input that allows the flame safeguard to cycle on and off as needed to control the process. This is the loop where inputs such as an operating limit or a control switch would normally be wired. Those are the limits that are normally turned on and off during a sequence. There may also be a fuel valve end switch interlock, which proves that the fuel valve is not open via mechanical switch. And that also may be referred to as a proof of closure because it means that the main fuel valve is actually closed, no fuel is going through. This input must be closed whenever the flame safeguard is in standby and until the pilot valve opens. So if the recycling limit has power, in other words the operating control and the control switch are on, that means there is a call for heat, and that initiates the startup sequence. First, the blower motor is started and a certain amount of time is allowed for the air pressure switch to prove airflow. The airflow switch is in the running interlock circuit, which may also be where some of the non-recycling limits are wired. If the airflow is proven, then the control will proceed to the next phase, which is a purge prior to ignition. This is commonly referred to as the pre-purge. The running interlock circuit may also have a requirement that the state changes from closed to open whenever the flame safeguard is in standby. That is to detect an airflow switch that is stuck closed, which would potentially allow the burner to proceed to ignition without the blower motor running. What that means is that you don't jumper out the airflow switch, basically, or that it actually does change state to prove that it works. Some flame safeguards even have an additional input to monitor the normally closed contact of the airflow switch. And if they don't have that, they just monitor that the airflow switch input is not closed. When determining whether to purge with an open or closed damper, and for how long, consider that the goal is to have a specific amount of complete air changes within the confined space. If an open damper is used, the airflow will be much greater, resulting in a shorter required purge time. If a closed damper is used for the purge timing will have to be longer, and it will begin when the airflow switch is proven. After the purge timing is complete, the flame safeguard will proceed to the next phase. And the reason a closed damper needs to be longer is less airflow is moved when the damper is closed than if the damper is open. If an open damper is used for the purge, the flame safeguard will command the modulating motor to drive to the open position. The flame safeguard may require that that open position is proven by the mod motor sending a signal to the purge interlock. The purge timing will begin upon driving to open when it is not proven, or if it does require proof, then when the open proven signal is received, it will begin purging. In both cases, once the purge timing is complete, the modulating motor will be commanded to drive to the low fire position. Once the signal is received at the low fire start interlock, the flame safeguard will proceed to the ignition phase. And those of you that have been in the boiler room know the cadence, the sound. You can hear the damper closing, and at the end of that you hear the pilot solenoid click. There are several different ways that ignition can be wired depending upon the burner. If there is a separate pilot valve, the ignition output will energize for a fixed amount of time while the pilot valve is also open. The pilot will then have a fixed amount of time to be proven before the sequence to establish the main flame begins. This period is either known as the pilot time for ignition, PTFI, or pilot flame establishing period, PFEP, and will typically last for around 5 to 10 seconds, and this is one of the timings that you can set with most flame safeguards, or that you choose. If the pilot flame is not proven, the flame safeguard will lock out with a pilot flame failure error. If the burner has a direct spark, the ignition output will energize at the same time as the main fuel valve, in which case there is no PTFI. There are two terms often used to describe the type of pilot that the flame safeguard supports, and many of you have heard these terms but maybe didn't understand what they meant. So one type is interrupted ignition. This means that the ignition is timed so that it is only energized when needed to light and establish the pilot. The other type is intermittent ignition. This means that the ignition is on all the time from when the ignition sequence begins until the main valve de-energizes to begin the shutdown sequence. So this could also be called continuous ignition. The main flame can either be established directly from a spark or it can be initiated from a pilot flame. If initiated from a pilot flame, once there is sufficient flame signal from the pilot during PTFI, and this is coming from the scanner, the main valve will open. The main valve will then have a fixed amount of time to be proven before the sequence to run in automatic mode begins. This period is known as main time for ignition, MTFI, or main flame establishing period, MFEP, and will typically last for around 10 to 15 seconds. If the burner has a direct spark, the ignition output will energize at the same time as the main fuel valve. The main fuel valve will have to prove in the amount of time described above, and if the main valve is not proven during the MTFI, the flame safeguard will lock out with a main flame failure error. Once the main flame has been proven, the flame safeguard transitions from the MTFI phase to the auto phase. At this point, the modulating motor is released to follow the commands received from the load control. The load control can be part of the flame safeguard or it can be externally mounted control. What the load controller is the unit responsible for maintaining the set point and may or may not also include a call for heat output. And the way the load control maintains the set point is commanding the modulating motor to go to a specific position to ask for a certain amount of output. When the call for heat goes away, the flame safeguard will prepare for shutdown. When there is no longer a call for heat, the flame safeguard will modulate down to the low fire position before turning off the main valves. This is known as assured low fire cutoff. Once the main valves are de-energized, the blower will continue to run for a period of time known as the post-purge, and once the post-purge is over, the control will go into standby phase and wait until the call for heat returns. So here's a summary laid out like a circle, because it does go in a circle at every cycle. It starts in standby, then goes to pre-purge ignition, PTFI, MTFI, auto, post-purge, and back to standby, and then the cycle will begin again next time there's a call for heat. So there are many reasons that a flame safeguard can lock out. If an input that is critical to the safety of the operation is not proven in time, a lockout will occur. So a lockout is basically a situation that's going to require user intervention or a manual reset. So the flame safeguard will not operate until somebody resets it and then addresses the issue. So some examples are the running interlock, which could be the airflow switch, a non-recycling interlock, and that could be a safety such as high temperature, high pressure, or low water cutoff. Purge interlock or low fire start interlock are the end switches on the modulating motor to prove that the positions have been achieved in time. And a lockout will also occur if the flame is not proven during the PTFI or MTFI. This is a flame failure, so main flame or pilot flame. A lockout will also occur if the flame goes out during run. And a lockout will also occur if a flame is detected when there should not be one, such as an extraneous flame. In some cases, you have a little bit of a timer there because when you're using infrared scanners, for example, you might have a residual flame signal when you turn the burner off due to reflections from the refractory. So there is some leeway that you can program into them with afterburn time. The manual for the flame safeguard should contain a sequence chart to show the desired status of inputs and commanded status of outputs for each phase. This chart can help determine if the particular flame safeguard or programmer will work for your application. So this comes out of a manual, and this is a sequence chart example. It shows you the line being up means on, the line being down means off. It just shows you when these different terminals should be on and off for the whole sequence. And this is only part of the chart. The chart goes through every terminal. And here's another example for a different product showing when the outputs and inputs should be on and off. So the manual for the flame safeguard will have all the information to describe each terminal on the wiring base and to provide an example wiring diagram. So here's a suggested wiring diagram for a BurnerLogix Y with a YP100 programmer. This is the example. Shows you what every terminal goes to in a pretty basic and generic wiring schematic. If a display is not present on the flame safeguard, it may have LEDs to help indicate the current status. Here's an example of our Burner Pro, and these are the LEDs that it has, and each LED has a certain indication, and the sequence can be read, as well as lockout codes, and all the information you need can actually be read from these LEDs if you don't have a display. The flame safeguard may also have a keypad display to provide more detail as to the current phase than the LEDs alone can. The display can also show the exact flame signal and lockout codes. The keypad display is also necessary if you want to make any changes to parameters into the flame safeguard. The keypad display can either be used as a service tool or can be left permanently installed. And the keypad display can either mount onto the chassis itself or can be remote mounted on the door of the enclosure. The flame safeguard may have a Modbus interface, which allows for an external device such as a PLC or building automation to communicate and get data. Remote commands such as enable, disable may also be able to be sent. The Modbus connections are typically serial, using RS-485, and addressing and communication is done with the keypad displays. So using RS-485 also can allow multiple flame safeguards to connect to one master device, and here's an example of a Modbus mapping. An expanded enunciation system allows inputs that are wired in series to a single terminal on the flame safeguard, such as the non-recycling or recycling inputs, to be individually monitored and enunciated on the keypad display. So multiple input strings can be identified, and a provision for labeling the inputs is usually provided, either via software or by entering onto the keypad. So this can dramatically reduce troubleshooting time, since the exact cause for a lockout or loss of call for heat can be easily identified. Instead of using a meter to check for voltage, you can actually see which input is not on. Pre-wired bases may also be available for the flame safeguard, and this will allow the installer to use pre-labeled leads of sufficient length to make the required connections, which would make installation easier. Pre-wired adapters may also be available to retrofit a flame safeguard onto the wiring base of another model, and this may help with retrofits of obsolete products. The adapter is designed to maintain the safety listing using the new flame safeguard. And this is an example of a Burner Pro that can go onto a 7800 subbase. So now we're getting into our specific FireEye flame safeguards, just an overview of each one. We'll start with the flame monitor, the E110 flame safeguard. And the E110 is a modular unit with many different options for programmers, amplifiers, and scanners. So the programmers, amplifiers will both be separate cards that will go into the chassis. There are also additional options available for expanded enunciation and as well as a display. There are outputs to connect to standard modulating motors with feedback via switches. So the flame monitor has been around the longest. It is a very large installed base. A lot of people are familiar with it, and many technicians are familiar with the model, and it has proven to be one of the most reliable and versatile flame safeguards available. So here's the base, and it contains the EB700 chassis, which can accept the required amplifier and programmer. There's also a 230 volt version. There's a wiring base, and we have two kinds, a surface mount and a cabinet mount. And the surface mount has conduit knockouts for standard use. There's a couple amplifier choices, and you will want to choose the one best suited to the application. So we have infrared, flame rod, and UV, and self-checking UV options. So this is just the chart with if you were to view this offline, you can get a little more detail. This and all the information for the flame safeguards also comes from the bulletins on FireEye.com for that particular flame safeguard. But this is the listing of the scanners that work with this unit. Here's the different programmers that are available. With this unit, you have EP programmers and EPD programmers. The difference is the EPD programmers have an integrated display. There are many different settings for the programmers. This is how you would choose which one you wanted to use. So based on the features that are listed in this matrix, you pick the part number you want. Some of the options can actually be set with dip switches on top of of what's listed in the selection, so there are some options that you can actually change. You can get a remote display for the flame monitor. A display is required for operation, so if you don't have an EPD, if you have an EP, you can get the remote display. If you have the EPD and you want an additional display, you can get the remote display as well. But you need to have one display at least. The E300 is the expanded enunciator for the flame monitor, and it can enunciate up to 16 additional interlocks. You can use E300 software to create custom messages for each interlock. A wiring base and ribbon cable are also required to make the connection. And when you use the E300, the messages from the expanded enunciation are displayed on the flame monitor display. Modbus is available from the EP or EPD programmer using a connection board and cable, and Modbus for the flame monitor is RS45 at 4800 baud, and you can have multiple units with different addresses connected in a daisy chain. So what is available from Modbus is all of the current operating information and from the base unit and the expanded enunciator, as well as the complete lockout history. Next we have the MicroM Flame Safeguard, and this control has many different options for chassis, programmer, and amplifier as well. There's also options for plug-in boards with additional options for the MicroM. So the MicroM is an excellent choice for applications where space is an issue, it's very small, or when the flame safeguard that is customized to the specific needs of an application is desired. This has a large installed base in industrial uses, where every application has a little bit different requirements. So the MicroM has two wiring base options, just like the flame monitor, one for use in a panel and one for use exterior. There's a number of chassis options. So we have two different categories of chassis, and they're listed here. For each of those chassis, there is a list of programmers that you can use. So this is just the list of programmers to use with one chassis. So you can see there's a lot of choices with the MicroM. You can really customize it to what you need. And here's the list for the other chassis. The programmers have LEDs to indicate the operating status of the control. So you can see the LEDs on the right. They're also used to indicate the lockout code if you don't have any, if you don't have a connection to read with Modbus what the lockout code is. Dip switches are provided for any option relevant to the particular programmer, so the dip switches are on the right at the bottom. MicroM has different amplifier options, and they're all listed here. We have a UV self-check, flame rod, infrared, standard choices. Here's the scanners you can use with the MicroM. The amplifier has test jacks that allow a multimeter to be used to test the flame signal in volts DC, so it makes it easy to test. It shows on the image 4 to 10 volts DC is what you'd read. There are a number of plug-in options available. If the chassis was not ordered with the proper option, you can add that later for reset switch, display output, remote reset, Modbus, etc. The same display, the ED510 that you use with the flame monitor, can be used with the MicroM, and it can be connected using a plug-in option module that supports a remote display. And you can get several different options with the plug-in modules because some of the plug-in modules contain more than one option. Modbus RT was available from the plug-in option board using terminal blocks. And the connection is RS45 like the flame monitor. Also 4800 baud with an address selectable using the display. So you can connect multiple units together, daisy chain, which is the way you would connect multiple units with Modbus RTU. And the units don't even have to be the same model. You can connect a MicroM to a flame monitor as long as they all use the same baud rate. And all the current operating information as well as the lockout history is available via Modbus. So next we have the BurnerLogix, starting with the YB110. So the YB110 Flame Safeguard has several base units with different amplifier options. So the base unit itself contains the amplifier. That's what's a little bit different about the YB110. Programmer modules are used to control the sequencing and display options, and expanded enunciation is also available. There are outputs to connect to standard modulating motors with feedback via switches. The YB110 is a more modern flame safeguard unit that is designed to fit most applications with one of the programmers available. The YB110 is also optimized for use with parallel positioning systems such as the PPC 4000 and PPC 6000 from FireEye. And the YB230 is the one you would use for 230 volt applications. We also have the BurnerLogix ZB110, And it differs from the YB110 in that the outputs to the modulating motor are 4 to 20 milliamps, although the feedback from the motor is still from the end switches. The ZB110 also has an internal load controller, a PID controller, that connects to a temperature or pressure sensor directly for firing rate control. So you don't need to have an external load controller or modulating control. The ZB110 has most of the same options as the YB110, except for the flame rod and direct coupled amplifier versions. Some of the programmer features, such as revert to pilot and low fire hold, are also included in the base unit directly. Programmer modules are used to control the sequencing and display options, and expanded enunciation is also available. And we have the ZB230 for 230 volt applications. So there are multiple wiring base options for the BurnerLogix. There's a closed base with half-inch knockouts, and an open base and a pre-wired base with color-coded wires that are 48 inches long, which makes it a lot easier to wire, or a lot quicker to wire. Here's a listing of the base models with the different types of amplifiers. So as I said, the base model, or the chassis, actually has the amplifier integrated. So if you get a YB110 UV, that's going to take UV. YB110 IR is the model that would take IR, etc. The programmers fit into a slot on the side of the YB110 chassis. And I'll back up real quick so you can see where it would go on the chassis itself. And it would go on the side of the unit where it says YP100. That is the programmer card. So programmers fit into a slot on the side, and this is a listing of the different programmers. And these each would have different operations, such as recycle, non-recycle, different flame fail response times, etc. So you choose the programmer that best fits your application. So the different programmer settings are specified in the chart here to help ensure that the correct model is chosen. And some models have different options that can be used with alternative wiring arrangements, meaning if you wire different ways, you can use the options differently. And that's listed here in one of the charts. For example, terminal W is igniter, terminal 6 is pilot valve. And if you wire them different ways, you can get slightly different outputs. Certain parameters can be changed before they are burned in, and the changes are made using the connected display. And this is a listing of those. And these would be things such as the timing for PTFI, MTFI. If you're wanting to prove purge interlock and low fire start interlock, some of those settings can be changed. The settings here that are shaded in yellow are settings that you can change anytime, even after the burn-in period. For the BurnerLogix, we have a number of scanners you can use, and they're all listed here. And again, that's in the bulletin for BurnerLogix as well. So there are two displays available. The BLL510 is an LCD display, and the BLV512 is a VFD, vacuum fluorescent display. So either module can be mounted directly to the YB110 base chassis or can be remote mounted. Now the difference is the LCD display is the one that maybe you're more used to seeing with the yellow background and the green letters, and the VFD, the vacuum fluorescent, is the dark background with the bright blue letters. So it's a little bit easier to see. Depending on the situation, you would choose the one that you would want to use. The YZ300 expanded enunciation can enunciate up to 4 recycling and 16 non-recycling interlocks, and custom messages can be entered for these using the YZ300P software. A wiring base and ED580 cable are required to connect to the chassis, and the messages are then displayed on one of the two displays that you connected to the YB110. And for the expanded enunciator, we also have a YZ320 for 230 volt applications. And the image on the right at the bottom shows them connected to each other. Modbus is available for the base unit using the ED610 board and cable, and the connection is RS-485. Very similar to all the others, except with this one, the address and baud rate are selectable. Connecting multiple units together in a serial chain is still possible, and the units don't have to be the same as long as the baud rate is the same for all the units, and the addresses are different for every unit. All of the current operating information from the base and the expanded enunciator, as well as the complete lockout history, are all available using Modbus. Next, we have the SB series flame safeguard, which has several base units with integrated amplifier options, so they're built into the base unit. A display option is available. There is also an option to connect to standard modulating motors via feedback with switches. The SB series is well suited to the industrial market with many configurations available to fit any application. This makes the wiring less complicated since the control has exactly the features needed, The SB series is also a direct replacement for the Eclipse VeriFlame flame safeguard and can mount on the same wiring base. There are two wiring base options, one for mounting in an enclosure and the other for external mounting with half-inch knockouts. The SB series can also mount on an existing Eclipse VeriFlame wiring base. Since all the options are included in one unit, the options are specified by the complete model number. So this matrix would show you how to create a model number based on the options that you wanted. The scanner selection is here. So there are two UV scanners, a flame rod, and a self-checking UV scanner option available for the SB series. Remote display SB510 is available, and it is remote mounted using a cable. So you would mount it on your enclosure. The last flame safeguard we have is the Burner Pro, and the Burner Pro flame safeguard has the base, programmer, and amplifier, again, all in one unit. There are three models to choose from. There's the basic unit, a Modbus unit, and a Modbus with valve proving. The Burner Pro is well suited to any application where space is tight and ease of use is a must. The small size makes the Burner Pro ideal for multi-burner applications, and the Modbus interface makes it easy for the supervisory PLC to manage. The Burner Pro is also a direct replacement for the Siemens LFL flame safeguard and can mount on the same wiring base. The Burner Pro mounts on this wiring base that we have, and it can also mount on an existing Siemens LFL wiring base. All Burner Pro models have integrated UV and flame rod amplifiers, so both of them, and either or both can be used at any time. Modbus models also have user adjustable timings when using the Config Wizard for Burner Pro software, or the BP410TS touchscreen. 6 preset timing models are also available for ease of replacement without the need to reprogram, or without the need to program. So we have S1 through S6 preset timings available so that you can change out quickly without having to change the settings with the software. An existing flame rod can be used, and we also have 2 UV scanners to choose from. There are 7 smart LEDs displaying operating information as well as enunciating lockout codes. So this is what they look like on the left, and they all have a specific meaning. And if you see the chart on the right, it's just a snippet of a lockout code. It shows you which LEDs would be illuminated for different lockout codes. The Burner Pro has a Honeywell 7800 adapter available pre-wired to fit popular 7800 bases, and the Burner Pro can either mount directly on top of the adapter or in another location beside it using the pre-wired cables that are attached to it. The Config Wizard for Burner Pro is software that allows changing your timings or other configurations of your Burner Pro. The BP410TS touchscreen is a 4.3-inch touchscreen that is able to connect to up to 32 Burner Pro models for detailed operating status, and can also be used to program timings either as a permanently installed item or as a service tool. So you can get one of these just to use to change timings and then take it with you as well. So I hope that you guys enjoyed that and that was informative. I'm going to try to put this available to view offline, and I have all your email addresses. So my name is Carlo Zaskorsky. My email address is carlo.zaskorsky, CARLO.ZASKORSKI @carrier.com if you have any other questions. And thank you guys for watching.